This lesson is about law of cosine. Law of cosine applies to a oblique triangle. So what is oblique triangle? Oblique triangle, take a look at the blue triangle on the left. So oblique triangle is when none of the interior angle is a right triangle. So you see the angles A, B, and C, right? None of them is 90 degree. So we call this an oblique triangle. So when a triangle is oblique, law of cosine explains the relationship between the three sides and the three angles. So in the previous lesson, I introduced law of sine. What's the difference between law of sine and law of cosine? So law of sine, so you see the formula right here, right? So that is law of sine. Law of sine is you take the A, B, and C in pairs, in fraction. So you put them in fraction and then set them equals to each other. That is law of sine. Law of cosine, the way I memorize this is you start with a letter and end with the same letter. So let's take a look at the first formula. You start with a c squared, right? And then you end with a cosine c. That's how I memorize. What else do I know? Other than c, you have a and b. So you have a squared plus b squared minus 2ab times cosine c. So this one is not too hard to memorize. Again, you start and end with the same letter. Length side measurement on the left, angle measurement on the right. So this is true for B and A. And again, the sum of three interior angles is always 180 degrees. We will need to use these properties multiple times when we do problem solving. So let's solve a couple examples. Before we go into that, every time I introduce law of cosine, students ask me a very good question. So now we have law of cosine, we have law of sine. When I solve a problem on the test, my teacher is not going to tell me, hey, this problem use law of sine, hey, this problem use law of cosine. They just give me a triangle and then ask me to do the job. In this situation, which one should I use? When I was a student, here is how I look at the law of sine and law of cosine. So for law of cosine, you see that law of cosine applies to two types of triangle, right? Side angle side, SAS, and side triangle, SSS. And then law of sine applies to three types of triangle. I don't want to memorize all five types because the memory is not going to hold too long. Here is how I do it. I will just go ahead and apply law of sine. If that doesn't work, what do I mean doesn't work? If I end up with one equation with two unknowns, I change the numbers around, law of sine doesn't work, then I know it must be law of cosine. So the idea is, again, you try law of sine first. If it doesn't work, try law of cosine. Either one of these will work. That's how I do law of sine and law of cosine when I was a student. So let's take a look at the first problem. So I have side A, side B, and then I have angle C. I want to find the rest of the information. Information means the measurement. So number one, I have A equals to 3, B equals to 4, and then big C equals to 40 degrees. The first thing is you draw an oblique triangle. It doesn't have to be perfect. The A, B, and C, I go from left to right. So this is A, this is B, and then C is equals to 40 degrees. And then on the opposite side of A, I have side A. Opposite side of angle B, I have side B. And then opposite side of angle C, I have side C, which is something that I don't know yet. So since I don't know C, if you recall the formula of C, so C squared, and then that ends with a cosine C, right? So I have A and B in the middle. So I have A squared plus B squared minus 2AB, and then cosine big C. You plug in everything you know. So you know A, you know B, you know big C. You plug in everything you know, and then you can calculate C. So that is equals to 3 squared plus 4 squared minus 2 times 3 times 4 times cosine of 40 degrees. And then you do this in your calculator. So C squared is equals to 25. And then minus 24 cosine 40. So this one, if you want to avoid all the round off error, you take the square root right there. Do we need to take it a plus or minus? The answer is we disregard the minus because side measurement cannot be negative. The length of of one of the side of a triangle cannot be negative. So you take the square root of 25 minus 24 cosine 40 degree, and then you give me an approximation. Can we approximate the 25 minus 24 times cosine first? Yes, you can, but if you round that answer, and then you take the square root, you round it again, so you accumulate more round off error. In my perspective, I would like to do my best to avoid all the round off error. So we press second and then press the square key. So I have my square root and then 25 minus 24 times cosine 40. Could you close the parenthesis of the 40 for me? And then that is equal to around 2.57. So that is the side measurement of C. What else do we don't know? I still need angle A or angle B. Let's do angle A. So for angle A, I already know side A. I draw the formula first. So A squared equals to B squared plus C squared minus 2BC times cosine of A. So in this case, A is what? A is we don't know yet, right? So we know A, that is 3 squared equals to B and C. We know both. So that is 4 squared plus 2.57. Let's move this up. Square minus 2 times 4 times 2.57, and then times cosine A. We can take the inverse of cosine to solve for A. So cosine A, let's put the cosine A, that one on the left, and then the 3 squared on the right. So we have 2 times 4 times 2.57 cosine A. We put that on the left. And then the 4 squared plus 2.57 squared minus 3 squared, we put that on the right. And then we divide it by the number in front of cosine. So cosine A is equals to right hand side divided by left hand side. 2.57 squared minus 3 squared divided by 2 times 4 times 2.57. And then to solve for A, we take the inverse cosine. So A is equals to inverse cosine. Yes, you use degree mode. 4 squared plus 2.57 squared minus 3 squared divided by 2 times 4 times 2.57. And then you will get the angle measurement for A. So we do second cosine, we get the inverse cosine. And then this one I actually calculated the top and bottom. So if you calculate the top, that is a 13.6049. And then the bottom, 2 times 4 times 2.57 is equals to 20.56. 56. And then close parenthesis for the inverse cosine. So you have around 48.6 degree. So now I got A and C. So to solve for B, I have to use the sum of 3 interior angles, 180 minus 48.6 minus 40. So that gives me 91.4 degree for angle B. So that answers this question. If you ask me, hey, it looks like after we got angle C, so I have a full pair of A, and then I have a full pair for C, big C and small c, and then I have a small a but not the big A. So that means I can use law of sine to solve the problem. Yes, you're right, you can use law of sine after you found C, but the purpose of this section is this lesson is we want to practice law of sine. So I will stick with we want to practice law of cosine. So I will stick with law of cosine when possible. But if you use law of sine, you will end up with the same answer. All right, problem 2. Let's change color for number 2. So number 2, I will draw the problem for you. So you don't need to go back and do the video to write down the problem. So number 2, we have A equals to 20, B equals to 29, and then C equals to 21. So this is a side triangle, right? You don't have any angle measurement. I will draw a triangle first to give me some visuals. So this is A, this is B, this is C. On the opposite side of A, we have small a equals to 20, opposite b, we have small b equals to 29, opposite side of c, we have c equals to 21. So we don't know any angle measurements. So let's go ahead to find a. You don't have to start with a, you can go ahead to find b or c, but I prefer to start with a. So since you are looking for cosine a, the formula must be the one that starts with a square. Again, law of cosine, you start on the same letter, start and end with the same letter. So let me also draw a note in here for you. So for the inverse cosine, you use degree mode. In case you didn't catch that in the previous problem. Oh, also, speaking of degree mode, in case you forgot how to switch to degree mode, you press the mode key. Every calculator, graphing or scientific has a mode key. Just look for it. So press the mode key. And then in this calculator, on the third line, I have an angle in radian mode or degree mode. So this one, I already set my calculator to be in degree mode. So to quick, for the graphing calculator, TI-84, TI-83, you press second mode. To quick. Second mode means you quick, right? So you see the word quick right above mode in the corner. So that means you want to go back to the home screen. Okay, a square that equals to b square plus c square minus 2bc times cosine big A. That's the formula. And then we plug in ABC. So 20 square equals to 29 square plus 21 square minus 2 times 29 times 21. And then cosine of A. So this one we want to... Let's do the square first. So this is a 400. And then the sum of those two squared is 1282. I'm not going to show you this. You can handle this. I'm sure you can handle it. So 1218 and then cosine of A. So you subtract the 1282 and then divide it by the 1218, right? So this one, let's put the cosine A on the left. So we have 1218 cosine A equals to 1282 minus 400, and then we divide it by the coefficient of cosine. So cosine A is 1282 minus 400 divided by 1218, and then you take the inverse cosine of it. So A is equals to inverse cosine of 1282 minus 400 divided by 1218. The reason I didn't do the subtraction and division first is because I am sure that if you take the numerator divided by the denominator, you have to do some rounding. I want to avoid round off error. So we do second cosine. Oh, this one we have a division. Then we need a parenthesis on top. So that will be 1282 minus 400, and then you close parenthesis for the subtraction, divided by 1218, close parenthesis for the division. Be very careful. If you do not use a parenthesis to wrap the subtraction, that means you are doing the division first because of the order of operation. If you use no parenthesis, they will take a 400 divided by 1218 first. So that will give you a huge mistake. All right, use parenthesis. So this is equal to 43.6 degree. 43.6 degree. So I just got my angle A, and then true. You can use law of sine starting from now on because you already know a full pair of A. True, that is true. But the purpose is I want to practice the law of cosine, so I'm not going to use law of sine at this point. So the next one, I am going to find angle B. So I have to start with B. AC minus 2AC, forgot the square, and then cosine big B, you plug in. So 29 square equals to 20 square plus 21 square minus 2 times 20 times 21, and then cosine of B. And then you evaluate the square, that is easy. So 841 equals to 841 minus 840, and then times cosine of B. So, and then you have cosine of B. I want you to do this in one step. We take 841 minus 841. I know that is equals to 0. This is not a mistake. you divide it by A40, that is equals to 0. All right, so we have cos B is equals to inverse cosine of 0, that is equals to 90 degree, right? So inverse cosine, look at my calculator, of 0, that is equals to 90 degree. I know what you are thinking. You are thinking about this, right? So you are thinking about that in a unit circle, at this point, the pi over 2, the 90 degree, you have 0, 1. Also, at this point, the 3 pi over 2, you also have 0 and negative 1, x equals to 0 in both cases. Yes, you're right. In theory, that equals to 90 degree and 270 degree. You are totally right. But is this a possible answer? Can one of the angle be 270? No, the answer is not. This is impossible, because if one of the angle is 270, that is already greater than 180, right? The sum of three angles is equals to 180. If you have one angle that is already greater than 180, then this is not a triangle anymore. So the 270 is not going to fit into this problem. So now you have A, you have B. To find C, all you need to do is you take 180 minus A minus B. There you go. That is your C. So that is 46.4 degree. So that's how you find A, B, and C. All right, in the next problem, I want to do more than just a law of cosine. So other than finding the rest of the measurement, I want you to use law of sine to tell me, is there a second triangle? So the next problem is a mixture of law of cosine and law of sine. So this time I am giving you an opportunity to practice both law in the same problem. Let's switch color to green. Number 3. We have B equals to 5, and then C equals to 12, and then big A is equals to 60 degree. All right. You have B, you have A, you have C, right? So A is equals to 60, and then on the opposite side, you have small a, but we don't know what small a is. And then C is equals to 12. C is equals to 12, and then B, we don't know B either, do we? Oh no, B is equals to 5. All right, so let's find A. Okay, let's find A. So let's find A. So A squared is equals to B squared plus C squared minus 2BC, and then cosine A, again, start on the same letter, start and end with the same letter. 5 squared, 12 squared, 2 times 5 times 12, and then cosine 60 degree. So this we can do everything at once. So A squared, that is equals to 109. I know you want to see how I do it. So we have 5 squared, and then plus 12 squared. So there is a quick square key on the left side of the comma key, and then times 2 minus 2 times 5 times 12, right? So that is 10 times 12. That means you are subtracting, just type it out. 2 times 5 times 12, or you can do 120, and then times cosine 60. Again, my calculator is already in degree mode. So you have 109, and then A, you don't do the minus, the square root of 109. So the square root of 109, there you go, is around 10.44. So A is around 10.44. So according to my direction, I would like you to use law of sine to find the next angle measurement, and then tell me, is there a second triangle in this case? So the next one that I will be using is, I will be using sine of A divided by sine A, that is equals to sine of B divided by sine B. So A, I have 60. This one you can use the approximation or you use the 109. I am a person who tries to avoid round off error, so I will use the exact value 109 in square root, and then cosine b, and then small b is equals to 5. Oh, I forgot to put the angle measurement, right? So this is supposed to be 60, and then you cross multiply. What is cross multiply? You do it like this, cross multiply. So we have 5 times sine of 60 degree equals to root 109 times sine b, and then sine b is equals to 5 times sine of 60 degree divided by the square root of 109. Let's take the inverse sine. So we have b equals to inverse sine of 5 times sine of 60 divided by the square root of 109. So inverse sine, we have 5 times sine 60 divided by the square root of 109. No, not there. Close parenthesis for the entire inverse sine. We have 24.5. So we have b is around 24.5 degree. And then that is my A. So I have A, I have B. C is so easy to find. So C is equals to 180 minus 60 and then minus 24.5. So C is equals to 95.5. So the problem is halfway done. All right, the problem is halfway done. Now, how do you know that there is a second triangle? So to answer this question, let's switch color. To find a second triangle, I have to use the 24.5. One thing that I want to remind you is I want you to look at your unit circle. We have two angle measurement. The first one is a pi over 6, so that is a 30 degree, right? So at pi over 6, what's the coordinate? The coordinate is root 3 over 2, comma 1/2. So in this case, y is equals to 1/2. There is a second point that gives you y equals to positive 1/2. That is a 5 pi over 6. At that point, you have negative root 3 over 2 and then positive 1/2. So that means if you do sine, cosine, if you do sine of pi over 6, you have 1/3, right? This is simple. But if you do inverse sine of 1/3, you have pi over 6. Not just that, you also have a 5 pi over 6. How do you find the 5 pi over 6? All you have to do is you use the 180 degree minus the 30 degree. That is how you get 5 pi over 6. So that means in this problem, I need to use a 180 degree minus 24.5 degree. That equals to 155.5 degree. That is another possible answer for angle B. But is that going to work? Is the 155.5 working or not? Let's take a look at what is given. The other angle is A equals to 60. Okay, so if I take a B plus A plus the 60 degree, what do you have? This one is already greater than 180 degree, right? So the sum of these two angle measurement is already greater than 180 degree. So that means there is no room to fit one more angles to it. This is A, this is B. We haven't taken C yet. So there is no room for C because the sum must be 180. The 150 plus 60, you already take all the space, right? So it is impossible to fit C. So that means no solution. If you take this as angle B. So in this problem, there is one triangle. All right, so that will be all in this part. In the next part, I will introduce an application problem. So I see you there.